Star. Okay, as I said at the beginning, que today unfortunately I make a selection. Son example que I suppose que es important, ¿no? Que represent one concept. Now, because we have no time to do everything. I don't know why. In the class face-to-face, always I have time, but I don't know. Maybe it's hard online. Okay, just in case, I send, when the class is over, I send email that contain a link que connected with the YouTube. In the YouTube, you can see any solution. Okay? 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 Again, one polynomial inequality again. Factorization. Square root this guy, x squared. But the combination is in between 121 is 25 and 4. Because 25 times 4 is 100 and 25 minus 4 is 21. And the sign are minus and plus. Okay, everyone follow me, right? Now, this is elementary. Now, I can see here a difference of a square. And this is the sum of a square. Okay, you need to know, or you need to remember que it's prime expression. So the only guy that we can factorization is the difference of a square. And this stays the same. This is xx divided by 5 plus or minus. Okay. Okay. Now, this is my inequality that you can put inside the box. My new inequality after the factorization, right? However, I want to manipulate a little bit more because I know this guy, look, this term never is negative, always is positive, and never is zero. Therefore, you can, in this case, partial, total, partial no, full delete. So full, completely delete, 100% delete, no partial. Look, to say you can write this is equivalent to write x plus 5, x minus 5, really the answer. The solution for this inequality and the solution for this inequality is the same because this term is always positive. To make sense, this looks, you see graphically, this is 1, 2, 3, 4, y instead of 4, and the parabola opened up. You see that this parabola is always positive and never zero. And remember, in the selection, when something is positive, we can delete in the inequality because the control of the inequality have the negative, guys. Do you understand this or no? Sure? Okay, so I focus it. Go ahead.
No, yeah, we understand it.
Okay, good. Now I focus it in the critical value. It's obvious that the critical value in this example is -5 and +5. I do the partition of the old real number line. I repeat again, guys. Don't do the partition table and try to solve it analytically. It's not good for me, okay? It's not good for me. So the method is combination algebra with graphic. Okay, the partition is 5 and -5, so suppose 5 here, -5 here. I select testing point, maybe good testing point is 0, -6, and +6. Okay, now doing the table. Testing point. And the factor involved in the problem is only x plus 5, x minus 5, total. And the testing point is -6, 0, and +6. Ready. Substitution. This is minus, plus. This is plus, minus. Of course, minus because we have only one minus, and plus. Okay, I finish my table. Immediately I pay my attention in the last column. The last column gets the total is positive here and here. Okay? Entonces this part, this interval is 0. No, not good. The only good guy que pass the test is this interval and this interval. Of course, do not include the endpoint because my inequality is a strict inequality, do not contain equal sign. No equal sign, no endpoint. Entonces the final answer is from negative infinity to negative 5, parenthesis union 5 comma infinity. End of story. Any question? No problem. Do you follow me? Do you understand very well? So I propose you now, see everything is okay. No. We continue number 8. I like number 8. Number 8 is important. Number 8 and number 9. I select like important question. Again, raise the board. Yes or no?
Can I take a picture, make it smaller?
Take a picture. Take your time. Take a picture. Come on. Okay,
Thank
come
you,
on.
sir.
Okay, no problem. Number 9. Or number 8, sorry. Number 8. Number 8 is using the factor theorem to determine whether x minus c is a factor of the f of x. O sea, one polynomial is given. X cubed plus 2x squared minus 6x plus 8. And also, semicolon, one factor is given, que es x plus 4, no? Y I need to prove if this factor belong or no to the polynomial, no? Entonces, the only thing that you should do is doing the scientific division, no? X cubed, x squared, x1, x0, 1, 2, minus 6, 8, and divided by negative 4. Please, don't forget, can you take the opposite sign of this? Bring down 1, negative 4, negative 2, 8, positive 2, negative 8, remain the 0. Okay, good. This factor belongs to the polynomial. Good. See, the remainder is not 0. You see, number 9 gets not 0. Wait a second. Let me try to explain another thing. Another possibility, but I don't like this, is evaluate the function in negative 4. It is 0, no? Negative 4 here, plus 4 is 0, no? You evaluate here, and the original polynomial, no? You evaluate, look at that. It is negative 4 cubic plus 2 negative 4 squared minus 6 times negative 4 plus 8. I'm surprised. Let me see what is the answer of this. This is negative 64. This is positive. This is 16 times 2, no? 32. Positive 24. And this is 8. Entonces 24 plus 8 is 32, no? And 32 plus 32 is 64, no? This is positive 64. This is negative 64. The answer is 0, exactly what we expect. This answer is exactly the same distance. Super. Good or not good?
Awesome. Yeah.
Awesome. Okay, good. Let me see number 9, que is the opposite idea, no? It's the same idea, but you get completely opposite conclusion, no? It's x to the 4th power plus 12 x to the 3rd power plus 4 x to the 2nd power plus 40 x minus 96. The factor that I need to investigate is x minus 12. Okay, so I am doing scientific division. X to the 4, x to the cubic, x to the 2nd, x to the 1, x to the 6. The coefficients are 1, 12, 4, 40, negative 90. And the factor here is 12. 12 positive, no? Opposite sign. It's negative in the factor, is positive in the back. Bring down 1, multiplication is 12, is 24. And this is a, you see it doesn't work. When you multiply, wow, you put in a calculator, of course, 24 times 12, you get 288. You combine here, it's 292. When you multiply, wow, increasing the number, is 3,544. When you add in this guy, 3,500. Oh, this is 04. This is 44 here. And when you multiply, wow, a huge number, it's 42,432. And you strike in this is 42,432. Sorry, this is, wow. This is 500. You can verification with your own calculator. If you want, no. 520. There was the multiplication, this times. The remainder is not 0, therefore the answer is no. This factor do not belong to the polynomial. You can verification in the same way if you want. And the other, but it's not important. As you, I promise if you evaluate f in 12, the answer is exactly the same. Super. We are the best. Good. Keep going.
Awesome.
Okay, so I propose you now 11 questions. So my selection, I do 11. 11 is, let me see in the review, in the package. It's given the maximum number of zero of the polynomial function may have using the Descartes rule. The Descartes rule of sign to determine how many positive and how many negative zero we have in the polynomial. No? And the polynomial expression is minus 6 x to the 9th power plus x to the 5th power minus x to the 2nd power plus x. Immediately, I make a reflection. I replace x for negative. Similar idea for the symmetry, to prove the symmetry. It's obvious that neither, because we have a combination odd exponent and even exponent. So the combination, see the polynomial contains only just even exponent, entonces es even function. Si contain just odd, depends. You have independent coefficients or no, because this independent is even function. Even, odd is neither. Well, in this case, you know, when you replace that, the only thing that change is the term that contains exponent odd, opposite sign, and the rest stays the same. So this is even, nice, stays the same. And this is also even, no? Stays the same. Odd, even. Okay, now yeah, analyze now the chain of sign problem. Using. Okay, it's negative. Remember the Descartes rule. Let me refresh your memory. Negative and positive. One chain of sign. Positive, negative. Another chain of sign. Negative, positive. Another chain. The capital P is the amount of the chain of sign we have, a 3. And the number of positive here is equal. You're subtracting 3 minus even number. 3 minus 0 is 3. 3 minus 2 is 1. And 3 minus 4 is negative. No. So it's no more. It's just 3 and 1. So the conclusion is we have 3 positive or 1 positive. I don't know. Here, let me use in another color. Positive, negative, 1 chain of sign, stay the same. Negative, negative, and negative, positive 2. So capital M is 2. Now the negative, positive 0, or negative 0, sorry, is 2 or 0. Today is a complicated day because we have, I grade the test. This is the students. you know, some students don't agree with the grade. I am picky guy. I am very, very picky. Okay, entonces, in conclusion, this is the option. Total, we have 9 because the degree of the polynomial is 9. We have 3 and 1, positive 0, and 2 or 0, negative 0. Entonces, what option you believe can work perfectly? 3 and 1 positive, 2 and 0. I suppose que option D, no? They are not good. The picture, understand this is, look. Remember we're doing some table like that, plus D, minus, complex and total. The one possibility is 3 positive, like that. 2 negative, like that. Total is 9. Entonces is 5, no? It's 4 complex. And the complex is coming by pair. It have no sense to put here odd number, always even number. Another possibility is 1, 0, 1, 0, and 9 here, therefore it's 8. Another possibility is 1, 2, 1 and 2, 6 and 9. And one last possibility is 3, again 3, repeat 3, 0, 3 and 0, 3 and 0. I take that. 3 and 0, 9 and 6. Okay? I don't get exactly what the combination actually work, but the thing they want is determine the maximum number of 0, or maximum is 3 positive and 2 negative. That's it. Any question? You want to do one more of this or no? It's stupid, right? It's super easy or no?
It is, Professor, but I got a little lost when we were counting for negatives again on the function. The first one you got 3. I can't remember exactly what it was that we did.
Slow down, step by step. The part that you don't understand very well is that part?
The one on top. Yes. That one and the one on top.
It's super easy. It's super easy. Listen to me. When you replace x for negative x, the only terms que change is the terms que contain odd exponent. Okay, for example, this is 9, it's odd, change, negative, positive. This is also odd, positive, negative. But they even know it stays the same. Okay, negative, negative, and this stays the same. Do you understand this part? Yes or no? Sir? Okay, keep going. Do you want, honestly, do you want one more example or no?
I'm good. What about anybody else?
Okay. Come on, opinion. But quickly, okay, for today. No? You feel okay in Descartes rule?
We're good. We're good.
Okay, super. Okay, entonces I propose you switching to 14. 14 is easy. 14 is just, let me read exactly what they want. They want a list the potential rational zero of the polynomial function. Okay, you have a polynomial function. In that case, is 6 x to the 4th power plus 3 x to the 3rd power minus 4 x to the 2nd power plus 2. Now remember, this is the famous theorem que es P over Q, no? Plus or minus. It's a formula, no? P is this guy, this is P, and this is Q. But basically, I have plus or minus. So you have a fraction, big fraction. P is 2, and the combination of 2 is just plus or minus 1 and plus or minus 2. That's it. And the combination of 6 is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, one fantastic way to determine this multiple is if you multiply here, like that, you get always 6, okay? And here is 2. Okay, now ready for determine the list. The list is, open the curly bracket. Suppose there are many ways to do, but I start navigate one by one for the denominator. No? So you take 1, so this divided by 1 and 2 divided by 1. So it's obvious que plus or minus 1 in the first and plus or minus 2 in the second. I finish with this. Don't. I care. I move on to the 2. It's 1/2 plus or minus 1/2. And again, 2 over 2 gets 1, but I have here, not necessarily repeated. Because remember the set is not illegal, but it's a stupid repetition. No? It's the same items, so not necessarily repetition. Okay, I did that. I move it to 3, it's 1/3 plus or minus 1/3, and plus or minus 2/3. Comma. I finished that. Finally, plus or minus 1/6, comma, plus or minus 2 over 6, but 2 over 6 and lowest term is 1/3. And 1/3 I have here. Done. Final answer. This is the answer. It doesn't matter the order, no? Okay, you listing this. Is plus or minus 1, plus or minus 2, plus or minus 3, no? Okay, what do you consider as the answer? I suppose que I don't know. No, I know. It's B, no? Let me know if I am doing selection correct or not, because I am super bad in the selection. That was number 14, no?
That was B.
It's B, okay. Okay. That's I guess. This was 14. Okay. Do you want to do one more of these kind of problem? Determine the listing. So we have basically 4, 14, 15, and 16. Do you want one more or no? Or you feel comfortable?
Not me.
Okay. And the rest, guy? Okay. Let me go to 17. Go ahead. Come on, I am here. Any question?
No, I was saying I was good for now, Professor.
Okay. Do you want to say? What do you say? What do you want? What's your problem? What's your question?
No. I'm saying we're okay. I'm okay for now.
I understand. Okay, super. I want to raise the board. Raise the board. Nice. Okay, I propose use 17. If we have time, we come back and use select. Okay, 17 is basically different. Using the rational zero theorem again, but they want more. They want, can you find all the real zero of the polynomial function? Using the zero factor over the real number. So you have polynomial, okay. Okay, no problem. They want you using again plus and minus p over q, no? It's the same idea, no? But they want more. They want after that use selection and factorization. I don't know, or using scientific division to determine the real zeros. Okay, the p is obvious is 25, and the factor of 25 is plus or minus 1, plus or minus 5, and plus or minus 25. That's it. Okay, because 5 times 5, I sell it 25, 25 times 1 is 25. And here is 1, wow. So the list of the potential real zero is just plus or minus 1, plus or minus 5, and plus or minus 25. It's exactly the same. The thing we have in the top, because the bottom is 1, and 1 is invisible. And plus or minus include both signs, positive and negative. Okay, so we come back to my polynomial. Yeah, I need to find the real zero. Okay, suppose que belong inside this list. I don't know exactly what is that. The one possibility is doing by scientific division. Another possibility, in this example specific, is easier, in my opinion, is factorization, because this is relatively easy. This is x squared, 25 and 1, no? Because 25 times 1 is 25, and 25 minus 1 is 24. Positive here and negative here. Super. I finished the factorization? No, of course no, because we have here a difference of a square. Remember, the sum of the square is impossible factorization. This expression is obvious que priming. And priming means that we cannot break it down at least in the real field. And the complex, of course, the reason is that the solution is complex. But in this case, no. In this case, we have x, 1, 1, plus and minus, que is the real solutions. And the real solution is when you put it equal to 0. This is no 0. This is you discard that part. One solution is positive 1, one solution is negative 1. And that's it. This is the way que they want. They want. Wait. Something. Okay. Good. Es de option D, ¿no? Es de option D. We see. Yeah, es de option D. Do you understand very well the idea for this? Is important in the next test. It's important que you identification que this kind of binomial is prime or is called also irreducible quadratic expression. Irreducible quadratic. And the situation happens when it's complex solution. Suppose que es minus, no, es nice. Si es minus, es nice. It's different of a square, and the factorization is x plus 5, x minus 5. But no, it's not the case. Super. You feel good? I propose doing one more of this because it's important. So let's do it now 18. Okay, it's similar. So we're doing at the beginning. So we determine P or Q. You determine the list, and you determine the real zero, maybe by factorization or maybe by synthetic division. 18 is f of x equal x cubic plus 2x squared minus 5x minus 6. Again, I start plus or minus p divided by q. This is p and q is 1. Nice. I like q is 1 because q is 1 doesn't affect. This is my list. It's invisible. And this is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And the list of the potential rational zero is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now, let me determine inside the list what is it actually satisfy the original polynomial. Well, okay. In this case, by factorization, it's impossible. Right? So you try factoring by grouping here, you are stuck in one moment. However, we need to apply more advanced method, is scientific division. Okay, factorization is extremely weak. Factorization is for the student in college algebra. Scientific division is a little bit more sophisticated. So you try an error. Recommendation, you put in decimals this equation, and you are a smart guy and determine what that. However, this is not good for me because this is not cheating, but it's okay. I need to, can you prove in the paper algebraically this idea? So I select 2. Sorry, the coefficient is 1, 2, minus 5, and minus 6. No? Let me see the original. Bring down 1. 2, 4. You say 3, 2 times 3 is 6. 0 remainder. Wow, I proved the factor x minus 2 below. Again, I can see 1 or negative 1. Bring down 1, multiplication is negative 1. 3, multiplication is negative 3. Again, 0 remainder, therefore the factor x plus 1 below. Remember, this sign is completely opposite to this. We continue, no, because degree is 1, so this guy is x plus 3. Okay, so actually the factorization for this polynomial is without factoring. It's x plus 1, x minus 2, x plus 3. And the zeros, the real zeros is obvious. Real zero is x equal negative 1, x equal positive 2, and x equal negative 3. I suppose que es de option D, ¿no? ¿O no? Miguel, ¿es option D correcto o no? ¿Es correcto o no? Yes or no? Okay.
It looks good to me.
Okay, very good. Okay. I try to find a new problem. Okay, let's do it now. 23. 23. I select 23. Because the rest is easy. Okay, no. Let me see. See, 23 case. 23 is solve the equation in the real number system. In other words, the thing they want is, can you find the real zero? The x in a set. It's similar, but expressed in different way, but it's the same stupid idea, no? 23. 23 is x to the 4th power minus 5, x to the 2nd power minus 36 equal to 0. This is another function, it's equation. And they want to solve this equation. Of course, this equation contains 4 solutions. But I suppose, according to the problem, or the, well, no, I don't know. Okay, we have, sorry, they want only the real solution. We have 4, but I don't know if it's too complex and too real, or 4 real and 0 complex, or 4 complex. It's possible. Entonces, in this case, it's obvious que by factorization is the best way, because it's trinomial, easy piece, okay. X squared, and the combination is 9 and 4. 9 and 4, right? 9 times 4 is 36, and 9 minus 4 is 5. Therefore, this sign is negative, and this sign is positive. Again, we have the situation in which this is the difference of a square. We continue the factorization, then factor completed. But this, unfortunately, is irreducible quantity. Stay the same. We cannot factorization, at least in the real field. And the factorization is xx33 plus or minus. So this is the guy that give me a complex solution. I don't care complex solution now. No. I care the real solution get negative 3 and positive. Que in my opinion is the option B. Okay. Now I want to. You have no question? You have no question? No? Okay. So I want to explain in detail now 24 and 25. If you want, I do 26 because it's interesting. Okay, and this is it's easy, but it's weird. Easy, but it's weird. We have in 24, we have equation. But this equation is crazy because we cannot do factorization. No. no factorization. Equation is given, and also it's given one interval. R represent, I don't know, root maybe. Root is equivalent to say x in a set. Okay, of the polynomial subject. Entonces, they want que you investigate this. Entonces, we use one idea que I never explained. I want to explain now, que is called intermediate value theorem. Que is relatively easy or super easy to understand. I want to explain in a few seconds. Suppose this is my all real number. Entonces, you have, I don't know, polynomial function. Remember, polynomial function is continuous. That's the most important idea. In continuous, we have no whole, we have no gap, we have no asymptote. No. This is not for the polynomial. Polynomial is move curve. Entonces, for example, if I want to investigate specific in one interval here. Si we have 1, 0 or no, it's easy. Well, no, by factor, impossible. Scientific division is impossible, too hard. However, I do in different way. Look, I select the endpoint of the interval, que is -1 and 0, I suppose. This is 0 and this is -1. I want to investigate if this polynomial have or no 1, 0 and inside this interval. Entonces, sí, yo evaluate the polynomial en 0, yo evaluate the function en 0, que es my first endpoint. The answer is obvious, que es -3, ¿no? And you evaluate en -1, the polynomial. So you evaluate in the endpoint. In this case is -1 cubic minus 8 times -1 plus -3. This is 4, positive 4, because let me see, this is -1 plus 8 minus 3. -1 and -3 together is -4, and 8 minus 4 is positive 4. Okay. So I discovered, wow, it's completely opposite idea of this. But it's the same idea. Look, this is my interval, -1, 0. I evaluated -1, and the answer was positive 4. And you evaluate in 0, and the answer is -3. Entonces, yeah, entonces, and also my polynomial curve is smooth. Entonces, en one specific, at least in one specific point, passing through, crossing the x-axis. Okay, this is the idea. So when the one is negative and another is positive or opposite sign, no? One is negative, one is positive, you discover que yes. But they want more. They want que you determine what is the value of this intercept. And then the only possibility that we have is graphical. Entonces, I go to Desmos to investigate this idea. This is the problem 24, no? 24. Okay, I go to Desmos. Look at that. I create Desmos. By the way, I sent to you the link of this Desmos or never I sent to you? Never. Let me copy. Yeah, I sent or I don't? Hey!
I never got.
Okay. I need to send. Send link of Desmos. Specific Desmos for the review package. Okay, look at that, what happened in 24. In 24, I have this situation. This is my function, look. This is my function, I copy here. Sorry, do you see Desmos now or no? No? Sorry, I always...
I can't see that.
Okay, I can't. You can't.
No, we can't see it.
No.
I know. Okay, sorry. Boom. Switching. Do you see now?
Yes, sir.
Oh, look. What was the thing I did? Well, I only put the function, the polynomial is given in black color. I put an interval here. Immediately, you can see the interval and the color that you prefer to highlight. I make a zoom. Wow, this is the guy I want to find. You click on the curve. This is the value. The value is minus 0.382. That's the answer. Do you understand? So the only possibility is you see. I put these questions in the test. The only possibility you have to investigate is proof algebraically using intermediate value theorem, que yes exists. That the theorem say exist or do not exist. Si both are positive, no. Si both are negative, no. Si both one positive and one negative, yes, exists at least one zero in the middle. Therefore, the value are graphical. You do the graphic and that's it. Okay?
So to clarify, on the test, you want us to use decimals.
Absolutely.
Okay.
I'm more, Joyce, I'm more. Look at that. I recommend.
Okay.
I recommend. Wait. I recommend que the graph que we are doing, you are doing in decimals. Entonces now you can print now the graph in one piece of paper. You took a picture, you put in a scanner, either way, but not do the graph in the paper by hand. And horrible graphic, I don't understand anything. No, I want beautiful, nice graphic. Okay? Do you follow me? Do you understand what do you I try to explain?
Yes, sir. I do.
Okay. You see the board again?
Yes, sir.
Do you want to do one problem similar to this or no?
Yes, we can see the board.
Okay. You see the board?
Yes.
Okay, super. My question was, you want, can I do one problem similar to apply again?
Yes.
Okay. 25, suppose 25. 25, the function is x to the fourth power minus x to the third power minus 7x to the second power plus 5x plus 10. And the interval is given is, let me see, 25. The interval is given is from minus 3 R and minus 2. Let me see. Yeah, minus 2. Yeah, 25. Entonces yo evalué the polynomial and the endpoint. You evaluate minus 3. Okay, I skip the arithmetic part, of course, 40. The answer is 40, and you evaluate in negative 2. And the answer is negative 4. So what do you think? Exist or do not exist? The zero in the middle.
Yes.
Exist.
Yes.
Yes. Does.
Okay, now to find the value, graphic decimals. Let's do it. Move on to decimals. Okay, may try. Switching. Oof. Cancel. Decimal. Okay. Do you see decimal now? No.
Not yet,
No?
sir.
Yeah,
Not yet.
Okay. Now, yes, no?
Yes, sir.
Okay. Forget about 24. No more 24, now 25. 25 is, I copy my polynomial, look. I copy my interval. Look, the polynomial I use in, let me use in black color. Because you see much better black color. This is the curve of the polynomial, 4 degree. Now the interval is in between -3 and -2. I use in green color. Let me change the color to red color to see much better. Red color. So I discovered, wow, look at that. Exists one guy inside the interval, okay, close to 0. I click on the curve. Yeah, I determine the value. The value is -2.236 approximately. It's approximate because maybe this value is no exact value, it's not real, it's real, but it's irrational. So to find this analytical is super complicated. There's some polynomial we need to solve them graphically. And this is one fantastic way to determine if exists or not. You say, do not exist, okay, no problem. Entonces, I don't need to find anything. That's it. Any question? Any question? Any question? No problem.
The question is going to ask if it exists, if it doesn't exist, and then we just answer yes or no.
No. The question is both. The question is exist or do not exist, and if exists, determine the value. Is it the question have solution R and the interval indicate? Approximate the solution correct in 2 decimal places. Well, you round, si es 2 decimal places, entonces 2.24, right? Que es the answer is negative, no? Negative. The answer is C, no? And the study guide. Correct? Correct?
Yes, sir.
Okay. Okay, let's go to the 27. 27 is important. It's important, extremely important. And not too easy to understand. Look. Okay. Let me erase everything. Erase everything. Good. Okay, I propose you now do 27. 27 is 27. 27 is 4. 4 is create a polynomial of x with the real coefficients having the given degree and 0. The specific 27 say que the degree is 3. Entonces 1, 0, o the 0 en plural que es given is -2 and 1 complex que es 3 plus I. ¿No? Okay, then I know that we have 3 solutions, 3 zeros. 1 real que es -2 and the complex, remember, is coming by pair of conjugate. The other que es omit intentional is 3 minus I. So you need to know by concept that the complex solution is coming by pairs of conjugate complex number. You see, give me 1, another is the wife or it's the husband. I don't know si es positive or negative. Okay? Entonces now, actually we have 3. My polynomial, okay, when I format that polynomial, I know that we have 1, 0, que es el -2, therefore I put +2, and we have 2 complex, que es this and this. So the complex, you write like that. I put a square bracket because I like it, not necessarily square bracket. Remember, the typical format of the one factor of the polynomial is x minus c. Entonces this c es -2, entonces doble minus become positive, or this c is this entire complex number, no? That's the reason I copy like that. Do you understand this idea? And this is the final answer. No, I need to multiplication. You apply for it. A strong recommend doing the complex part first. Why? Because when you are doing the complex part first, magically, you see now happen that the imaginary part is canceled out. Okay, so you apply for it. Just for it. You multiply x times x squared. You multiply x times this complex number minus, parenthesis, 3 minus I, x. This and this is minus 3 plus I, x, and finally plus, minus plus 3 plus I, 3 minus I. So far, everyone follow me? So far, everyone follow me? Okay.
Yes, sir.
Now the super interesting part. I don't know if you remember what happened when you multiply one complex number times its conjugate. One fantastic thing happened. If the answer is just real, okay. I suppose I don't remember anything. I don't remember color algebra. I multiply 3 times 3 is 9. 3 times I is minus 3i. This is positive 3i. And this is minus I squared. This cancels. There is a reason, I anymore, because I know I squared is negative 1. Therefore, this is 9 plus 1. Double minus become positive 10. So what a shortcut to do in 1 second. 1 second. You multiply 3 times 3 is 9. This 9 is this 9. Always plus, because can one moment happen that we have double minus que become positive, and coefficient here is 1, coefficient here is 1, and 1 times 1 is 1, and the answer is 10. It's a shortcut to do in 1 second. But basically, this guy is 10. Okay? Now the rest is pretty easy. So you remove the parenthesis minus 3x plus ix minus 3x minus ix plus 10. I want to erase that part. Do you understand very well the multiplication of the complex number? So it's a special case, it's a special multiplication, is when you multiply any complex number times its conjugate. To conclusion, number one, the answer is real, amazing. And number two is the multiplication first, hour, or last. Finally, oh, look at what happened important. This gets canceled. No I anymore. So we have x squared minus 6x plus 10. End the story. This is our polynomial. This is our expression. This is our final answer. But I suppose I'm making a mistake or no? Of course I'm making a mistake, coño. I forgot. Remember, this is not the final answer. No. This is the partial answer of the multiplication. This guy times this guy. Now, after I need to multiply x, but this is the easy part. X plus 2 times x squared minus 6x plus 10. You apply big FOIL, x cubic, minus 6x squared plus 10x plus 2x squared minus 12x plus 20. Plus 20 or minus 20? Let me see. Could be right or could be wrong. Plus 20 here. Plus 20. So finally, we have x cubic. We combine light term. Who is light term? This is light. This is this and this is light. This is minus 4x squared. This and this is minus 2x plus 20. X cubic minus 4x squared. I suppose que es the option A. Any question? Do you want me to do for you one more similar to this or no?
Let us take a picture, sir.
Go ahead.
Can you make it smaller, please? Thank you, sir.
Do you need another similar to this or no?
I'm okay.
Are you okay? Okay. Everyone is okay? Because it's the same repetition. Different number, of course, but it's the same repetition. Okay, si one student need, let me know now. Okay, yes, what mean yes? Feli Valde, what do you say yes? One more yes, Feli, or no? We go to another. I understand. Feli say, I understand. Okay, okay. Okay, so I propose you doing now 32. Get the last one. And after, when you finish the last one, why not? We are doing another, no? Because at least we have time to cover everything today. The last day I dedicated too much time, but it was necessary, I suppose. Okay, 32 gets the last one. Let me see what is exactly the question that they want. They want find all zeros. When you mean all zero include real and complex of the function and write the polynomial as a product of linear factor. Okay? So in this case, it's more open. So we need to determine all zero and write. We're doing 32. 3x to the 4th power minus 4x to the power plus 28 x to the 2nd power minus 36x plus 9. Well, let's do it by scientific division because by factorization is crazy. Okay. My recommendation is in this moment, you put this polynomial in decimal. And you are smart and you can see the real zero. Yeah, I discovered, okay, this is x to the 4th power, x to the power, x to the 2nd power, x to the 1 power, x to the 0 power. The coefficients are 3, negative 4, 28, minus 36, and 9. Here I perform scientific division in 1. Because I saw in decimal that 1 is real, 0, but I need to prove for the professor that this is true algebraically. I bring down 3, multiplication, and negative 1, is negative 1, is 27, is 27, and negative 9, and this is negative 9, 0 remainder. I prove that the factor x minus 1 belongs to this. And also, I can see in this 1/3, positive 1/3. And so the positive 1/3 is bring 3, multiplication of 1 is 0. Multiply is 0, 27, 0, 27 plus 0 is 27, and 27 times 1/3 gets divided by 3 is 9. And the factor x minus 1/3 is also belong to the polynomial. Okay. One detail, sophisticated detail. No exactly super important, but I like is when you have fraction here, you can avoid the fraction. How? You factorization 3 out. No, you factorization 1/3 out, sorry. You factorization 1/3 out. And you have 3x minus 1. Let me see if this idea is good or not. I remove the parentheses, multiply 1/3 times 3 is 1, and 1/3 times 1 is 1/3. This expression and this expression are equivalent. But what's the difference? The difference is that inside we have no fraction. We have the fraction as coefficients, and you see now what happened with this 1/3. Surprise. I go back to this. This is x to the 0, this is x to the 1, this is x to the 2nd, no? Actually, this polynomial is 3 x to the 2nd, missing x to the 1, no, plus 27. And you can see, wow, 3 is common factor. I factor out x squared plus 9, no? But you put together, when you put together this polynomial in factory form, well, you put the first factor that was, look at that, 1, x minus 1, nice. You put the second that was 1/3, 3x minus 1, And you put the last one, que es 3x squared plus 9. It's cancel. Surprise. And the answer is x minus 1, 3x minus 1, x squared plus 9. And the real field, in the complex field, we can separate, if you want, when we need, because it's all real number, the irreducible quadratic expression, que es this, like x minus 1, 3x minus 1, entonces xx, but this is square root, the negative is 3i, positive and negative. And this is a factorization in the complex field. This satisfy perfectly the thing that they want, because they want to find all zero. Well, what is the all zero? All zeros are x equal 1, x equal 1/3, because this fact when you put it equal to 0, x equal minus 3i, okay, this guy, 3i plus 3i, and this positive 3i. This is all zeros, and the factor product as a linear factor. Yes, a factorization is this. Okay, entonces, what is the answer, guys? Well, in my opinion, this is the answer. Complementary, if you want to show me in detail, you write something like that. Any question? Okay. Guys, you are advanced students. The other class I have one class of the intermediate algebra. Intermediate algebra. And another class is college algebra. These students are the mess. And give me the test horrible, and no wrong solutions. Right by hand, I cannot understand. Okay, so try to do like a masterpiece, clear, page by page, or depending on the questions. The question is not as short. We can put in one page to question, depending the question. It's up to you, using your imagination. But I need to see clear answers and beautiful graphic using decimals. Okay. Let me try. Okay, stop
Let us
sharing.
repeat, sir.
Sorry. Carajo. Okay, let me try again. Okay, there you go. Okay. Okay, entonces,
Thank you.
if you have no more questions, you want to do one more? Okay, let me prepare my second computer, because the intention is send to you the test, no? So you stay in the line, and you receive, you say, Professor, I got it, right? Okay, let me try in the second computer. Email you. And you. Okay. Carajo. Email. Okay. You copy? You take a picture? Was good?
Yes, sir. Thank you.
Okay. And the subject of this email I put the MAC 1140. Test number 1. That is due. What is due? What is due?
29.
29, sir.
Tuesday, no? Next Tuesday. Yes or no?
Yes, it's due on Tuesday.
Absolutely. Next Tuesday is 29, no? 29 September. September
Yes.
29. 29. As always at midnight. And it's also due the test online. You know that, right? Both. Online, due that day. Okay, let me try to find attach MAC1140. That's number 1. Okay, now I need to put your email address now. Okay. Now, email address, your email address. I copy and paste. Boom. Boom. Okay. I sent. Let me know if you receive or no. Guy, I am very, very picky. I am picky guy. Try to do your best. I suppose you have no problem. You get 100, 110. Remember, in the test online, we have 10 extra points for the homework part.
Is there a password for the practice test?
No,
Okay.
no password.
Okay.
Any problem, any complication you see, okay, any situation you inform me.
Okay.
I don't, some people don't send me text. Immediately, shoo, I send. I do not receive your text. Sorry, I have emergency. Emergency? You need to inform it to me. Authorization. I can extend a little bit. I can or you don't. Okay? This is a school. School have schedule and school have discipline. Do you receive or not yet?
Oh, we still
Yes.
see the whiteboard in the back. I still see the whiteboard.
You receive? You receive?
I'm looking.
Yes. Okay. Okay, good luck. I wish you good luck. Okay, super.
I got it.
Enjoy.
Okay. Thank you so much.
Great,
Thank you,
as always.
Professor.
I got the email.
Okay.
Thank you, sir. Have a nice day.
You do, miss.
Thanks for the lesson.
Now I download the video. Okay. Stop.